Hello and welcome. Thank you for joining us for the How to Get Through Transportation Plans and Performance for Construction events. My name is Melissa Finley, and I'm a research engineer at the Texas A&M Transportation Institute. I am the moderator for today's session, but before we get started, I want to go over a few housekeeping items. First, ITE would like to thank the champion sponsors, Gannett Fleming, Siemens, Transsoft Solutions, for their support of the conference, and Kimley Horn for sponsoring this week's sessions. In today's sessions, we will have speaker presentations first, followed by Q&A, and then some discussion. We encourage you to type your questions into the question pane as they come to mind throughout the session, and we will address as many of those as we can following the presentations. If the session ends before all the questions are answered, some of our speakers may be able to spend some time in the Wonder Room. To access Wonder, go to the conference platform where you selected this session and select the hallway talk. Then go to the technical sessions area. At the end of the session, we'll confirm with our speakers who will be able to spend a little time in the Wonder Room. Your attendance in this session includes PDH credits. The link for receiving PDH credits is shared in the chat box, so be sure to save that link for access later and to complete the post-session evaluation. The recording of this session will be available in the ITE Learning Hub within 48 hours for all meeting registrants. Now I would like to introduce our speakers. For today's session, we have Tyler Craig, Professional Traffic Engineer, Alliant Engineering, and Vanessa Munoz, Director of Engineering, Wildan Engineering. We have Mark Masongsong, he is CEO and founder of Urban Logic. Shane Binder, Transport Engineer from Wakamiriki District Council, and Michael Koslow for Senior Engineer, City and County of Denver, Colorado. And we also have Jingjong Q. I said that wrong. Let me try that again. Jinghua Xu. There we go. Senior Associate, Fair and Peers. Thank you. Detailed speaker bios are listed on the website under the session description. So let's hear from speaker one.
We want to thank all of you for tuning into our presentation today. We'll be presenting on the Transportation Management Plan of SoFi Stadium for the City of Inglewood. I'm Tyler Craig of Alliant Engineering.
And I'm Vanessa Munoz of Wildan Engineering. SoFi Stadium is located in the city of Inglewood, California, a southwestern city in Los Angeles County. The stadium was built on the old Hollywood Park racetrack parcel and was chosen due to its proximity to LAX Airport and being one of the largest available sites in Southern California. The stadium will host 20 NFL games by hosting both the Chargers and Ram NFL teams, which will alternate home games every week. In addition, the site can be used for large events such as concerts, monster truck shows, WrestleMania, and other big-ticket events such as Super Bowl 2022, College Football National Championship in 2023, and the opening and closing ceremonies of the Olympic Games in 2028. SoFi Stadium, together with the Forum, a music and entertainment venue located 1 block away, were planned to serve as a destination for folks to visit, shop, dine, and be entertained.
But putting in a new stadium is never without its challenges. For starters, the SoFi Stadium is essentially right in the middle of the city of Inglewood. After review of the most recent stadium builds and a few classic ones, the average motorist distance to the highway is significantly higher with the SoFi Stadium. Obviously, this driver distance from highways isn't the most important metric, but it can heavily impact operations from signalized intersections, pedestrian movements, and other factors that bring friction to inbound and outbound traffic flow. The bigger point is that many other sites are close to the highways to push traffic into free flow operations quicker, whereas the SoFi Stadium exists on a grid network with multi-directional traffic flows, resulting in higher impacts at the core and on existing background traffic operations. So the big question is, what's the best way to get folks in and out?
Developing a stadium in the middle of a build-out city comes with challenges. The first challenge is SoFi Stadium is surrounded by mostly residential neighborhoods. Furthermore, Inglewood houses a large number of people of color and lower income residents. Due to the makeup of the city's demographic, the effects of gentrification and displacement are already felt, and building in a stadium only worsened those effects. When putting the traffic management and operation plan together, one of the primary missions was to minimize the impacts to the quality of life for the residents. And adding onto our big question, how do we get stadium visitors in and out while not negatively impacting the quality of life for its residents? Another challenge is parking for the area. Inside Parking Stadium has a shortfall of 6,000 to 12,000 parking spaces, or up to 36,000 attendees, depending on the event's schedule and occupancy assumptions. There is a limited amount of parking that the City of Inglewood has available, 1,100 parking spaces, but it only puts a minor dent in the amount needed. And as noted in the last challenge, we want to avoid event-based traffic using the parking spaces that residents use in their daily life. So in addition to figuring out how to get users in and out in a way that doesn't impact residents, we also want to figure out different ways to get fans into the venue without parking on site.
To get a ballpark estimate on where the future vehicle traffic might be coming from, we use zip code data of where the past Chargers and Rams season ticket holders were located in developing this estimate. This data is a proxy and might not fully reflect the true conditions, but it allowed us a starting point to iterate from. We then percolated those numbers through a volume distribution model that factored in parking lots, preferred routes, modal splits, and more to determine the path that users might take, as well as determining critical points of congestion and possible signal timing updates through our analysis model. We also collected data at certain locations during normal operations to not only gauge current traffic levels, but also in developing flexibility by overlaying the event data over differing volume cases. This allows us to model unique situations, such as an event occurring during the PM peak at the same time as a forum event, or any other unique case we might be interested in evaluating.
We've talked about the challenges of this plan, but how do we address all of them? We've broken up the traffic management and operation plan into 4 key solutions: having traffic control officers at special intersections, stadium operations center, traffic signal timing, and transit and alternative transportation modes. The first we're going to discuss is the traffic control officers. We utilize traffic control officers at critical locations during event day operations. The TCOs ensure users are utilizing event day closures and geometric changes in a safe and efficient manner and get to observe what works and doesn't work for the future events. They also help to mitigate any on-street mishaps that may occur, like a minor crash or driver confusion. We expect a wide range of users on the city streets, including out-of-towners, and having someone point them in the right direction could drastically minimize effects when looking at a larger magnitude of visitors. And since we are prohibiting event parking on residential streets, traffic control officers help to minimize those impacts through presence and guidance. In addition to having eyes on the street through officers, we also have 2 event day operator positions in the Stadium Operations Center to view all operations of traffic, signal timing, and ITS needs through live camera feeds. The Stadium Operations Center houses key personnel from the city's traffic, maintenance, police, fire, and parking divisions to create a streamline of communication with the stadium. Central system is critical to the success of the traffic management and operation plan as it provides live views of traffic and is used to control the signal timing and arterial traffic flows.
A large part of our plan was developing adequate traffic signal timing. We discussed making everyday work for the city, and that goal was furthered by optimizing all of the city's 140 signals for daily use through creation of 3 to 6 timing plans. These plans progress vehicle traffic while still creating safe operations for pedestrians, motorists, and bikes by updating clearance parameters and walk times while still minimizing cycle lengths. When it came to game day operations, we created 3 total plans for inbound and outbound traffic that use varying flexibilities in their traffic volumes. These plans were able to be turned on system-wide or by corridor from the control center, creating the opportunity to enable the necessary operations where and when they're needed in a customizable way. Given the grid system of the area, we wanted to ensure that all of our corridors worked with each other on a cross-coordination standpoint. We also dug deep into creating systems of harmonic cycles, especially in the case of event operations. We're able to give higher cycles in the event core where critical conflicting movements are frequent, while creating half or even quarter cycles in the fringe and underutilized corridors. This allows for traffic progression without the unnecessary cross-street and pedestrian delays, speed increases, and non-compliant safety issues that long cycles can cause. Lastly, we were able to progress our priority routes, such as our transit-only routes or reversible lanes into and out of the stadium. Our last solution is related to getting people into the stadium in ways that aren't just parking on site. As you can see, we have many points to this, but we'll go over just the main ones. We discussed transit-only routes, which our major route is on Arbor Vitae Street, which is directly connected to the stadium's planned intermodal on-site transit center. In looking at other venues for the area, there's the ability to create a tailgate or party atmosphere off-site and bus fans in. Hollywood Bowl does a really good job of this, for example, where the shuttle becomes part of the experience, and we took a similar note in our 9 park and ride shuttle locations. The Crenshaw rail line isn't yet finished, but is anticipated to be a crucial aid in getting folks into the city and connecting Inglewood to the greater rail system for event traffic. We anticipate the line being open in 2022. The final touch is a rideshare center for folks that might choose app-based services to and from the events. These 4 major solutions really help to address the challenges the stadium might have with operations, parking capacity, and impact on resident quality of life. Now the table is set for some big events with tons of fans coming in to check out the state-of-the-art stadium. Let's kick off the events with Taylor Swift headlining the first opening event of 100,000 people. Now we all know what happened next, so we don't need to go too deep into that. But COVID-19 changed the plan for the stadium on top of the pain it caused in the rethinking of our current systems. The good news is that just like the rest of the world, we were able to iterate our plan and make things work out. Also, it got Taylor to put out Folklore and Evermore, which, as a non-Swift fan, are actually pretty good. Anyways, back to the point.
Under COVID, there were some major hurdles to overcome, not only in our daily lives, but also in how the traffic management and operation plan for SoFi Stadium was previously envisioned. Construction schedules were impacted, funding sources frozen or eliminated, and traffic patterns changed. However, one positive note came out of it: the luxury of extra time. This allowed the city to continue the build-out of the interconnect system, construct a more robust ITS system, fine-tune details of the plan, and determine if priorities changed and how to address them. In addition, we were able to develop more flexible and phased operations that could more accurately reflect the slow ramping up of traffic volumes, activities, and events in general as restrictions are lifted. The ability to test our plan over an iterative process versus one large event is also extremely beneficial to fine-tune the process over time.
With all of this plan adjustments, we were lucky enough to have smaller events to determine any of the parts of the system that might crack under higher traffic event levels. The city uses SoFi as a vaccination hub, and that helped us determine at which point is a threshold that we utilize the event plans. We also had a small concert for limited attendees to celebrate healthcare workers, featuring Selena Gomez, J-Lo, Foo Fighters, and more. A Rams scrimmage also provided the opportunity to test out on a fan base that'll be more similar to the large-scale event of the NFL. From these smaller events, which we were able to monitor remotely through cameras in the central system, we were able to make further tweaks to our plan when kinks showed up in unforeseen locations. A lot of these were related to rethinking our operations of certain features when the unfamiliar public actually uses them, such as removing our planned left turn lane emissions at critical locations or rethinking our reversible lane configurations. We were also able to find any issues with processing times, such as ticketing or parking lot entry issues.
So our lessons learned and key takeaways were: keep lines of communication open. This includes all levels of city staff and officials, stadium operators, transit operators, and consultants involved. Deployment of the proper infrastructure improvements, including ITS, is critical to signal operations and plan success. Staying flexible and understanding that different size events require different approaches and that there's not a one-size-fits-all approach. And stay mindful of how the implementation changes affects those who live in the area by always looking for ways to minimize impacts to the quality of life of the residents. And last but not least, the old and true tested methods sometimes are the best solutions, and don't get caught up only with complicated solutions.
This type of project is a huge undertaking, and it's only possible with coordination from many different moving parts. Of all the departments in the city that keep things running, to the various consultants that help with traffic work, geometric updates, signal design, and interconnect, to the stadium team themselves, this was a huge effort. Here's a shout out to all of those folks involved. Have any questions? We do too. We haven't exactly had a big event yet, so we don't know how this whole thing will necessarily go. But we are being flexible as we phase in and test through smaller events as we return to normal, and are confident that all of our planning will work out once we return to having large events again in the fall 2021 NFL season. Any questions?
All right, thank you so much, Tyler and Vanessa. As Tyler just mentioned, if you have questions, please start entering those into your question pod, and we'll be able to see those. And after all presentations, we will be answering as many of those as we can. So next up is our next speaker, Mark.
Hello, everyone, and thank you for joining us. My name is Mark Song. I'm the CEO and co-founder of Urban Logic. I'm going to share with you a case study we did with the city of Ottawa about using modern data science and modern data sources to help them better manage large construction projects. And some of the methodology of how we got to our choice of data, the use cases, and some of the future ideas and learning outcomes. So some background of us. Urban Logic is a data analytics company based in Vancouver, Canada, and we also have an office in New York City. We started the company, I used to be a public servant, and the challenge I always had in government is that as a public servant, we know that governments collect a treasure trove of data, but the challenge is that as an individual public servant, it's oftentimes challenging for us to access that data in a time sensitive and a cost effective manner. So the concept behind Urban Logic was really to break down the data silos amongst a number of governments. We work with everything from the federal government of Canada, to state of Texas, right down to communities under 100,000 people. And they're all facing the same challenge, that there's an explosion of data. More data is being produced every year than all of previous human history in every given year. But the challenge is that the tools that public servants have to access that data really isn't keeping up with the exciting opportunities of data. And data is oftentimes broken down into a number of different departments, agencies, jurisdictions, and even between the public and private sector, as we're going to show. So what Urban Logic does is we take a 4-step process. We aggregate all of the government's existing data, regardless of department, agency, jurisdiction. If it's something that should be made accessible to public servant, we consume it in one common operating picture. We then automate workflows, identifying what are the decisions and the insights that you're trying to arrive at. And then oftentimes that reveals where there is a data gap, as we'll talk about, we discovered the city of Ottawa. And that's where I think there's an exciting opportunity to marry the explosion of data from the private sector, but bring it into a public service context. And once you have that complete data picture, then you can use the power of artificial intelligence and data science to really get to some very exciting insights. I want to take a moment pause here and just stress that in today's day and age, obviously the issues of cybersecurity and privacy are forefront for all government leaders. And so one of the things that we stress is that everything we do and everything you're going to see is fully privacy compliant, whether it be the California Consumer Protection Act or the GDPR in Europe or Bill C-11 in Canada. All of these different types of privacy regulations, and whether it be NIST or ISO certifications around cybersecurity, all of the systems we built are compliant to those highest standards. So some background on the City of Ottawa. The City of Ottawa was building a major light rail investment in terms of public transit infrastructure. But one of the concerns was as you build these large constructions onto busy thoroughfares and in front of retail shops, the concern was how is this impacting local businesses, and how can the government best quantify the impact on local communities and minimize that impact. So the goal was using modern data science, could they identify the right time and place to do different types of construction projects? Can you then communicate to stakeholders, so whether it be small business owners or commuters, around it's best to avoid these roads at this time of day, Or if there was concerns amongst the business community who were opposing a lot of these projects, you could quantify to them that the impact on your business may not be as severe as you think. And of course, one of the challenges any day and age is there's always the goal to minimize taxpayers' expense and improve staff efficiency. And then finally, contractor compliance. So in a number of the cities we work with, construction companies oftentimes are told that if there's a threshold beyond which if your project causes congestion beyond these thresholds, there are financial penalties and the like. So can this support the government in identifying which contractors are operating within the bounds of their agreements, and can you enforce compliance on those standards? So the challenge that the city of Ottawa had was, first of all, if any of you have ever dealt with any type of road sensors or traffic counts, it's what you're seeing here is oftentimes just either Excel or CSV sheets, and they're spread amongst different agencies, departments, individual desktop systems. And so to get a complete view of traffic in a real-time manner was just not going to be possible within the time-sensitive manner that they were looking for. In addition, the city of Ottawa, if you're familiar with it, it is one of the coldest capital cities in the world, everything from hot summers to extremely cold winters, and that expansion and contraction of the road surface oftentimes tears up the road and damages road sensors. So it creates a challenge of getting accurate and real-time road sensor data. So that was where Urban Logic was brought in, and we examined a number of different data sources to see how you could supplement the city's mobility picture. So everything from connected vehicle data. So this is data taken off of, if you're familiar with, for example, General Motors OnStar system. So fully in a fully anonymized fashion, can you pull connected vehicle data around mobility patterns, so you can map how vehicles are using your roads. Cell phone data. So whether that's triangulation through cell phone towers or location-based apps. So fully anonymized origin destination data off of mobile phone apps. That also gives you a picture of how your citizens are moving. And what we ended up shorting the focus to was kind of two data sources. One was the existing bus fleets, so real-time bus location APIs. And they had a number of advantages. It was owned by the government, and it was something that provides a regular picture of mobility. But at the time, I think it's improved quite a bit since, but this was a couple of years ago. At the time, the ability to pull that data on a very frequent basis would have overwhelmed the system. And also, there were concerns around whether this was truly reflective of all the roads at all the times. So what we ended up, after testing a number of these data sources, we ended up focusing on Mapbox and HERE data because it was a large sample size. It offered us real-time or near real-time insights of mobility patterns. And so what we did is we built a platform that ingested that data, married it to the Ottawa mobility patterns, and then built on top of that a number of travel time analyses. So one of the first things that the benefits of this approach did is instead of having to measure the entire city, we were able to geo-select just the areas of interest. And this led to a massive reduction in cost because instead of having to layer sensors across the city or buy a citywide sensor database, we were able to micro-target just the areas of interest and make sure that they're only paying for exactly what they need to know. We used the City of Ottawa's GIS systems and we married it with them so that the city officials could then use the platform in a manner that they're familiar with to identify the areas of interest. We configured it to 5-minute increments. That way, you can micro-target specific changes on a given road segment or intersection to a high degree of granularity. And we built it in a way that instead of being a kind of a static picture of just these particular locations, the city officials could move their area of interest at any given time of day, any given area of the city, and just pull the data on a real-time basis of that area that they wanted to examine at that particular time. So here's an example of what the platform looked like. It allowed the government officials to pick a road segment and see what the travel times are on bidirectionally. You could also pick a number of multiple road segments and compare them. So given two road segments, which would be the most efficient at any given time of day if you're trying to optimize traffic routing. You could select particular time windows and get a sense of any given granularity, what that type of analysis you wanted to dive into. One of the other things that we're rolling out is a notification system. So for example, if the city has a threshold where if there is an unexpected, whether it be a car crash or any other type of unexpected congestion, instead of having to monitor 24 hours a day, 7 days a week with someone watching these systems, the system can actually detect when an unexpected period of congestion or a unacceptable level of road time is emerging, and automatically notify the staff. So that allows them to put their focus on elsewhere and only really put human eyes on something when it becomes pertinent to the city operations. One of the things that we're building on top of that now is there's enough data that you can actually start to build predictive measures. So you can see this is a test case where we made a prediction on every given road segment and every given intersection what speed and volume would be. And then when you go out there and you actually test against it, so the dotted line was the prediction and the solid line is the actual result when you actually evaluate the actual traffic patterns that day. So what this is allowing us to do is preemptively, if a construction company is going to do road network, we can actually look, a few days into the future. Our limit tends to be about 4 days because weather is a big impactor of congestion. But look at into the future 4 days and help them understand, like if you're going to need to tear up a road, this particular time of day is when you're going to have minimal traffic, and you'll have the ability to minimize the impact on congestion and travel time. One of the next steps beyond this is actually looking at where you want to be investing in infrastructure going into the future. So for example, using origin destination data, what you can see here is this is a particular bridge, and you can start to see over the course of the day how many people are using that bridge. And then going forward, using again location-based origin destination data, you can actually start to see where people are coming from and where they're going to. So this also helps with a lot of analyses we're doing with them around if you're going to be investing in certain infrastructure, are you doing so equitably? Are you overserving one neighborhood and one population and underserving another? And if, for example, this also opens up exciting opportunities around urban planning. If most of the people that are traveling from one jurisdiction to another and are crossing that bridge are actually coming from a given neighborhood, then maybe you can actually relocate some city amenities, services, or businesses to allow that to minimize the number of vehicle miles traveled. And then I think some of the lessons we learned coming out of all that is that there's a number of data sources being made available. So if you just think of mobility data, there's inductive loops, pneumatic tubes, manual counters. There's also now computer vision cameras, there's connected vehicle data, and there's, I mentioned, location-based app data. So one of the things that we stress is one data source isn't the best source for all use cases. What's important to understand is what are you trying to solve for? And what are the attributes you're going to need? And once you identify the attributes you're going to need to drive your insights, you can then identify the appropriate data source that you're looking at, and then even minimize the expense on it if you can only select the sample of data that you need just to cover your area of interest. One of the other points we'll make is that different types of data sources have different accuracy thresholds. So I'm happy to get into this in the Q&A. But for example, there might be a type of data source that is much more accurate during the day, but due to, for example, location-based app data, during the night when most people are at home in their beds, that data may be less accurate than connected vehicle data. And so you can actually start to look at even down times of day around what are the right data sources you should be using. And what you can also then do is once you build these types of data tools, a lot of people bring up the concerns of is the public going to be concerned that you're using this data, like as I mentioned, whether it be mobility data from cell phones or cars, and that is a valid concern, and that is, I think, a valid point that citizens have a right to bring up. But I think once there's transparency, and we've had experience in this with the City of Ottawa or City of San Jose, once you share with the public that this is how the data is privacy screened and this is what we're using it for, you can actually address a lot of that concern and turn skeptics into supporters. Help them understand that this is fully privacy compliant and it's being used to improve quality of life and environmental sustainability. And so I think as long as you have that mature conversation, you can get the public on board. One of the lessons that we've learned across this is that every day there are more and more data sources proliferating, and the privacy legislation and the government comfort with it is a little bit lagging. So just because a data source is becoming available, it may be legal today, but it might not be permissible for use in the future. So there are some risks around building dependencies around a data source that may not be available, at least in the manner you're currently using it, down the road. Now, that's not a reason not to use it, but it's just a point of keeping an eye on emerging privacy legislation and working with your vendors to make sure that it's future-proof. So that's where a lot of work Urban Logic does, is to work with governments to understand what are not just the rules today, but what are the rules you're considering, and how can we craft our product in a manner that even as new laws come on the books in 2, 3, 5 years, what we're offering to public servants is something that will be able to be stable and consistent going forward. One of the things I'd like to also point out, an exciting opportunity, is that more and more, as you get access to data, you learn new things. So when we originally started this project, it was really just to help construction companies minimize the amount of impact and congestion they cause on the roads. But it's now evolving rapidly to are we even building the right roads in the right areas? And are we doing so in a equitable manner? So I think those are some of the exciting opportunities that are going forward. I think as these projects evolve, we'll see a lot more of these systems come online, and with some exciting new use cases coming forward. So with that, thank you for your time, and I'm happy to take any questions.
All right, thanks, Mark. I want to remind everyone that we are taking questions in the chat box in the Q&A section. So if you would just make sure and go there and enter your questions. And then once we finish all of our presentations, we'll come back online and we will answer as many of those as we can. Our next speaker, Shane and Michael.
Thanks for that. And again, we're Shane Binder and Michael Koslow. Good morning from me down on the south side of the world, but we'll launch right into it. So we're here to talk through street and sidewalk closure policies for work zones. Give you a sense of the information we're looking to cover. We, as part of our work with the City and County of Denver on their work zone policies, did a bit of best practice research across agencies in both the United States and Canada, and then use that to set the stage for a complete overhaul of Denver's policies, including looking at some of the more technical and permit requirements, penalties, and fees, and try to pull out from that some of our lessons learned and takeaways if you're looking to do the same. So, as they say, imitation is the sincerest form of flattery. Here we've listed a number of the agencies that we either interviewed with or spent a lot of time browsing through their policies online. Don't expect you to take a look at each one of these right now. Hopefully the material will be available after the fact, and there's some very good information out there to see how other cities have implemented them. So as I noted, we went through and spoke with a number of agencies across North America to get a sense of how they had implemented either their initial work zone policies or more recent changes. And as you can imagine, such policies would have some interesting challenges and some great successes in their implementation. We were pretty surprised to hear, again, there was an increase in the consistency and quality of submittals coming in across all the agencies, but a lot of challenge on how to actually implement the policies from a staff training and I guess on boots on the ground perspective. And an interesting comment you can see there at the bottom from Pittsburgh, they were facing challenges in getting their more progressive policies to be taken up by PennDOT, the state DOT, which maintained a number of highways through the city and had maybe more lenient right-of-way use policies. So some sort of intergovernmental issues there. We also reached out to the agencies to get a sense of how they went through public notification, how they worked through closures and detours, a couple of some of the takeaways we have here. Interesting to note there at the bottom, as you can imagine, signing vehicular detours, a very common practice, and that was something strongly advocated by both Austin and the Oregon DOT. But Vancouver, Canada, which has a pretty comprehensive grid system, they actually in some instances would leave vehicular detours unsigned to really avoid concentrating traffic on routes that wouldn't see that much normally. So sort of some interesting food for thought there.
So as our agency started to take a look at DETOUR, which is an acronym, it does stand for Designing Efficient Transportation Options for Urban Rerouting, with the main goal being to have a multimodal perspective on construction detours and whenever the right-of-way is closed, including the road, the sidewalks, streets, bike trails, transit facilities, etc. So you can see some of the things that we had in mind. We were trying to keep in our agency had fees kind of ensconced into the document, so we wanted to consider pulling those fees out so that they'd be a little bit more flexible. We had an old document that did not have definitions of bike facilities in terms of having to do detours, so we want to introduce that, and then we wanted to also have a little more robust pedestrian protection in areas in our Vision Zero high injury network and what is in our citywide pedestrian plan. So those are kind of the main objectives getting started with DETOUR. And so one of the things we wanted to keep in mind was what was that prioritization when right-of-way is being closed. What we want to have, basically consistent permanent applications and technical requirements to be similar, to require the same closure times, the same signage, etc. And then last but not least, we have closures not just due to construction projects, but when we have events or utilities that need to close the road. Those are similar scenarios where we need to protect the general public traffic-wise. So one of the things that we wanted to, where we were starting with was we had our existing 2007 document, which is a rule and regulation we're looking to update. We wanted to figure out how to split up those technical things that we needed to have in constant rule and regulations and things that we could pull out and just have done a procedure. For example, if a contractor needed to include a canopy for pedestrians for work overhead, that might not need to be in a rule and regulation, for example. So when we were starting the project, we had three kind of key stakeholders. We wanted to talk with our advocacy groups, our bike ped advocacy groups, the contractor association, and our internal inspection and permit counter staff for DOTI, which is Denver Department of Transportation Infrastructure. And when we met with the, one of the things that we thought was surprising was we met with traffic control contractors. They wanted to see more details into the drawings as well. Things like a bus shelter, a fire hydrant, things that are a little bit more important for a pedestrian than the vehicles going through construction sites that are being detoured. We also helped us internally as Denver staff to help the inspectors understand that their role was more than just filling out paperwork for the contractors. They have a role in providing safety for the general public within public right-of-way of Denver. And that was something else that came out of this project.
So after going through our consultation, we started setting the baseline for the revised policies, and that started really off with going into our definitions. So a couple of thoughts out of that. You really want to consider all of your impacted areas within the right-of-way, go beyond your sidewalks, bicycle, and traffic lanes, and consider cycle tracks, off-road paths, even goat tracks. I think you want to consider whether you want to be defining certain premium or areas versus normal areas. In our case, for premium, we're considering sort of high value bicycle and pedestrian regions or areas with high safety needs, as Michael alluded to, including central business districts, universities, or shopping districts. Going back to this comment on the GO tracks, we actually defined a sidewalk area, which is a term we borrowed from Seattle, that effectively always deemed there to be a sidewalk area on both sides of any street unless there was a physical obstruction, which recognizes there could be a pedestrian demand that would be impacted by a work zone, regardless of whether there is a sealed path or not. We also defined what we called sensitive non-motorized facilities that consider these sort of high value elements of the streetscape that weren't necessarily first to mind, so maybe high value to pedestrians and cyclists, such as curb ramps, bus stops, push buttons, but other elements that aren't necessarily transportation related, but still of critical value, such as building fire exits, fire connections, and fire hydrants. You want to be careful that you are defining those and according them some value in your policy. And whenever possible, make sure you're linking everything as much as possible back to your municipal code. That gives you a bit of a stronger foundation on the legal side of it. With those definitions in place, then we set aside our sort of high-level prioritization policy. And I have to say, give hats off to Washington, D.C. for their fine example we ended up emulating for this. But you can see we set this up. This is the pedestrian model. There's also a similar one for cyclists, and effectively a contractor should be trying to meet point 1, and if they can't, they can try to justify going to point 2, and if they can't do 2, then they go to 3. And you see we have detouring pedestrians off of the impacted blocker blocks as the lowest on the prioritization, so the hardest to get to.
So when we started talking with our inspection staff within DOTI, they helped us with that definition of what would be a long-term closure versus short-term closure, right? You might have more notifications, more robust traffic control review, et cetera, if it's going to be a long-term. And so that number of 72 hours came from our inspection staff. One of the things that I also would want to reiterate that when we had a project, everyone was trying to discern, how much more is this going to cost to do projects. We were trying to put in a bus shelter next to a parking lane, or obviously it's a bus stop. Temporarily, the bus stop isn't there, and wanted to detour that bus stop or the pedestrians into the road. When we were realizing our traffic control is a lump sum on that contract, and it is on a lot of projects. So that makes it a little bit more challenging to discern, what would it cost, additional costs associated with these new requirements. One of the things that we would say in terms of permit requirements, we wanted to keep obviously you want to keep facilities open if we can, and otherwise consider, if we had to, go ahead and do a mid-block closure with a proper crossing mechanism like a signal or RFB or something like that in order to get pedestrians across the street. We would be doing that. One of the things that we've noticed is, and Shane's going to have a look at this down the road here in a minute, but that the fees are very, very different. And one of the ways you can encourage people to have, our contractors, to keep the sidewalks open is by looking at the costs associated with that sidewalk closure versus other facilities to close travel lane. So this giant chart here is meant to be an example of, if you're a contractor and you have work or an event, something closing a road, it has these different facilities on them. What are the things that you want to keep in mind? In general, for example, if your project is having a bike lane adjacent, that you need to keep that bike lane open as part of the detour, or have a detour for that bike lane if it's determined you cannot do that. So one of the things I kind of alluded to earlier is that, in addition to having this rule and regulation, which means essentially when we have a permit and something that there are costs associated with that permit from external partners versus a DOTI policy and procedure. For example, if you have a policy and procedure about when the canopies might be needed, when the contractors might need to have a parking plan associated with their closure, there might need to be certain lighting requirements, etc. Those kinds of things can be done in a policy and procedure and don't need to be in a rule and regulation.
We also were considering non-work zone related closures, and special events come to the top of that list. So you have fairly standard special events, races, festivals, and parades, and then you get into some of the more unique ones, such as block parties. Denver Days is an event that the city does citywide to really try to encourage neighbors to get out and meet each other. And as part of that, they try to make it as easy as possible to organize, including trying to minimize the challenges in getting a road closure. So we found in trying to accommodate special event closures that there was a lot of coordination required across multiple different agencies within the city that we otherwise would not have been speaking with. A couple other considerations, certainly you'd be looking at if you're doing filming for either television advertisements or television or movies. There are certain challenges in that the different requirements and, shall we say, agendas from the city film office. They're trying to work on the economic development side, and as well considering you might want to have different requirements and or costs for nonprofits, 501(c)(3) or events that are private, not open to the public.
So when we look at what we have contractors, a lot of times people we want to do the best job they can, but sometimes we have some poorly behaving contractors or ones that decide they don't want to follow their own permit requirements. Some of the things that we have in mind, in Denver, we have non-compliance fees and administrative citations. Essentially, administrative citation is by our right-of-way enforcement, so like a parking ticket. So what our inspectors would issue the contractors is a non-compliance fee. If the contractor continues this behavior, then we have to do the stop work order. Currently, the contractors are licensed through the state, and so there's no way to revoke any sort of contractor's license, even if they're not following their permits and putting the public potentially in danger. But what we can do is deny future applications, and as the R in revocable street occupancy permit stands for revocable, we can't revoke that permit if needed.
Even when contractors are behaving properly, there is a need to have a cost for use of the right of way. So we went through a bit of an exercise in trying to rationalize the fees that Denver charges. I think it's relatively easy to quantify the construction and traffic control costs, but it's a lot more challenging to quantify the costs borne by network users for delay and safety impacts, which makes this something of a challenge. Certainly, we're looking to use the fees to try to encourage or prioritize keeping some elements of the right of way open and using other ones for work zones. I would say a really good example would be look at Seattle. SDOT has an amazing structure where they define separate work zone rates for urban villages in the central business district, as well as blockages of a transit facility, bicycle facility, and sidewalks. They differentiate between full and partial closures, intermittent closures, and detours, and they have a nice online calculator to make that whole fee matrix far more approachable for contractors. For our purposes, to understand how different elements could be used and fees to encourage different elements to be used, we did something we call a standard block fee exercise. We went through a number of different cities and took a standard CBD block 300 feet long with on-street parking and an 8-foot sidewalk and said, how much does closing the sidewalk cost, 1.0, versus closing other elements of the right-of-way? And you can see if you wanted to prioritize keeping a sidewalk open, that you might make closing a parking lane a little bit less expensive. And so this is a means to not evaluate the specific cost, but the relative cost of elements across the right-of-way.
So if we had a little bit more time here, I'd probably get into this a little bit more. There's always more to be done. In Denver, our staff, fewer than 20 inspectors, has to manage over 20,000 revocable street occupancy permits a year. If we could put a little bit more on the contractor, we would. I think that's the end of the conclusion from the city's perspective. Thank you very much.
All right, thanks so much, Shane and Michael. I just want to remind you once again to make sure you're entering your questions in the chat pod. We want to make sure that we have lots of questions and time for Q&A at the end. Our next presenter, Jinghua, is going to.
Good morning, everyone. My name is Jinghua Xu. I'm the Senior Travel Forecasting Practice Leader with Fear & Peers based in Orange County, California. Today, I'm going to present our work to support evacuation analysis due to extreme conditions as part of the city planning process. This presentation includes 4 parts. I will first briefly talk about the background of this analysis, then introduce the approach and the methodology, followed by scenario analysis and typical recommendations based on the analysis results. The city of Rancho Cucamonga is located in the San Bernardino County in Southern California. The city is currently completing a comprehensive general plan update, which coincides with significant mobility momentum in the city as the high-speed rail connection to Las Vegas, the loop tunnel to the airport, and the continued connectivities of the city's roadway network are ongoing and upcoming in different stages of planning, development, and construction. The figures shown on these slides display the historical fire parameters that have encroached into the city since the 1960s. And in recent years, more and more wildfires and other type of hazardous events have occurred in the nearby regions. Given the comprehensive nature of the general plan effort and the increase in hazardous events associated with climate change, it is appropriate to assess emergency evacuation events. The assessment provides information on the capacity of the transportation system, estimated time to evacuate specific areas of the city based on specific events, and identify specific hotspots where congestion could occur during an evacuation event. This assessment could assist the city with information related to the evacuation events, and it is consistent with new requirements outlined in California Assembly Bill 747 and Senate Bill 99, which specifically requires agencies to evaluate the capacity of their evacuation routes and identify key routes with only one point of access. The figures on this slide display the typical hazardous areas in the city and the city's sphere of influence, which includes very high fire hazard severity zones, seismic hazardous area due to fault rupture and earthquake-induced landslides, as well as flood hazardous zones and dam inundation zones. As shown from these figures, it is important for the city to examine the current system to be prepared for evacuation of any potential hazardous events in the future. This analysis focuses on evacuation activities during an evacuation event. As such, this figure presents the planning process that was utilized to assist in addressing key issues during an evacuation event in the city's planning process. First, to define the evacuation route system, the resilient evacuation routes for the whole West Riverside County and the entire San Bernardino County were developed during the joint effort of the agencies in the region. Once the evacuation routes have been identified, we start to assess the system resilience. To assess system resilience, we first look at the travel distance required to get from evacuation area to safe location, such as evacuation shelters and external areas of the city, which helps to identify areas where accessibility is limited or long-distance travel is required. In addition to the accessibility assessment, we also evaluate connectivity consistent with requirements outlined in Senate Bill 99. This assessment identifies parcels that have only one point of access, typically because they are located at the end of a long dead-end road that has limited redundancy for accessibility. Another thread of the evacuation analysis is to assess evacuation routes. Assembly Bill 747 requires that the capacity of the evacuation system be assessed. Therefore, a dynamic evacuation tool, also called the EVAC Plus tool, was developed for this purpose to assess the system. The process of this dynamic evacuation tool is shown in this flowchart. The tool consists of three submodules, that is, sub-area module, evacuation module, and a DTA module. The sub-area module is to extract the sub-area from a regional roadway system, which includes the city and its neighboring area. In addition, trip tables for the sub-area are also generated for regular daily traffic flow. The evacuation module is to estimate the number of trips from the areas required to be evacuated. The vehicle trips were estimated by the existing land use and the socioeconomic data in the evacuation area. The socioeconomic data includes a variety of information based on census data, including data for population, households, employment, auto ownership, and other factors that could affect the vehicle availability during an evacuation event. The sub-area extracted network and new trip table from these two modules are then input into the dynamic traffic assignment module. The DT module estimates traffic and the levels of congestions on the 15-minute interval, and as link congestion builds, it dynamically reassigns traffic to less congested routes. The DTA is a more accurate way of estimating trip assignment and identifying congested location on the network that should be considered during an evacuation event. The outputs of the DTA module was used to assist with the amount of time needed for the evacuation and the roadway capacity assessment. In the scenario analysis, this tool was utilized to evaluate the estimated travel time for 5 evacuation scenarios, as listed in the table on this slide. The tool uses inputs from the travel demand model for a typical day and modifies the travel demand and the transportation network to represent the evacuation condition. After determining the evacuation travel demand and associated transportation network, a dynamic traffic assignment with 15 minutes intervals is performed to reflect congestion and the departure time to estimated travel time. This assessment assumes an evacuation event during the morning commute period to maximize population evacuation from primarily residential neighborhoods, but also including significant commute background traffic on the roadways associated with typical commute travel patterns. As the approach indicates, the first step is to identify the resilient evacuation roadways. The graphics on the left shows the identified routes in a much bigger region than the city. The sub-area procedure is applied to generate the sub-area roadway system for the city and associated table for the regular daily traffic. Two types of assessments are performed as the approach indicates. As required by Senate Bill 99, we identify 30 plus developed parcels within the city, as shown in the table on the left, which could experience evacuation challenges resulting from only one point of ingress and egress to the city's transportation system. The table in the middle shows the city's preferred evacuation routes and shelter location, which are the primary routes assessed as part of the analysis. The shelters are potential evacuation trip destination if not within the evacuation area. The two graphics on the right shows the distance from city TZs to the evacuation shelters and to the city boundary. The review of these two distance graphics identifies that areas lacking redundant access and having the longest evacuation travel distance during an evacuation event are the area north of SR 210, which is a freeway, east-west freeway on the north. Additionally, the southwest area of the city has been identified as having a further distance to the evacuation shelter during an evacuation event. The overall vehicle travel demand was based on the regular travel activity until the evacuation notice was issued. The travel demand for evacuation zones was separated from background traffic, which is not associated with evacuation zones. The number of resident anticipated vehicle trips per household and employees in the area were referenced to estimate the number of vehicle trips that would need to be evacuated. The DTA procedure assigns vehicle trips in the designated time intervals to simulate an evacuation scenarios. The DTA outputs of the tool for each scenario include dynamic roadway traffic condition in terms of time and the VC ratio for each time interval. Using the earthquake evacuation scenario, that is scenario number 4, as an example, the VC ratio plots on the upper right of the slides are shown for each 15-minute interval within the 1-hour evacuation time window, where the entire city needs to be evacuated. These plots are color-coded by VC ratio from green to red, green being free flow traffic and red being heavily congested, while the width of the lines represent traffic volume. As shown on in these plots, the street within the city start to show congestion at 6 a.m. when the evacuation starts. After the first 15-minute interval, the additional traffic and heavy congestion start to form in the center of the city and continue building up until all the evacuation trips are released. By comparing across all the scenarios, the 1-hour evacuation time window shows a more intense traffic load on the roadway than the multi-hour evacuation time window due to more dense release of the evacuation trips on the roadways in a shorter time window. The chart below the plot shows evacuation clearance time required for each scenario, and as it indicates, the clearance time increases when the evacuation area is become larger. Based on the outputs from the dynamic evacuation tool, we have conducted a comprehensive evaluation on the capacity of the roadway network within the city and identified the hotspots of the roadway system. At the end, we recommend to the city a range of potential improvements based on the analysis results. Some typical recommendations are listed here. For example, ensure redundancy of critical transportation routes to allow for continued access and movement in the events of an emergency. And then provide more flexible roadway design to facilitate additional capacity when needed. Traffic operation strategies, such as using the dynamic messaging message sign to guide the evacuating traffic, and then apply different traffic control to ensure that the intersection provides what will not be the bottleneck for the evacuation traffic. And the other strategies, of course, we also recommend other strategies that can be applied to enhance the accessibility and the capacity of the evacuation route. This concludes my presentation today, and then please feel free to ask any question. Thank you.
All right, thank you so much to our presenters. Now we're going to start the open Q&A session. So I'm going to ask the presenters if they will come back online. You can continue to ask questions. We do have several in queue already, but if you have a question, please feel free to enter it in the question box. I'm going to start back with our first presentation. We do have a couple of questions for each presenter. So in fairness of time, I'm going to ask one question kind of to each presenter, and then we'll go back through just to make sure that we cover a variety of topics and questions today. So our first question is for Tyler and Vanessa. It says, did you consider the difference between attendees at sports events who are likely to learn their routes and their pregame over time versus like a concert where you have loads of unfamiliar drivers?
Yeah, sure. So in addition to that, I just want to say that Vanessa and I and all the people who've been involved have been working on this for a long time. This is a huge project. There's a lot going on with it. So feel free to hop onto the Wonder after this. We could talk your guys' ear off forever. So, but getting to the actual question, we did look at the unfamiliarity versus familiarity. We kind of factored in drivers taking the worst possible route to their parking lot people from the north deciding that they wanted to park in the southernmost lot, or people getting lost and going around a couple times or something, trying to find a spot. We also coupled that with padding some of our critical movements, like our left turns, or putting in extra geometry. We modified the existing geometry from what was currently happening to both the pre and the post event. So with that, we're able to put in double lanes if needed. We at one point had done a reversible lane that we were thinking about. And we're also having, the other thing to deal with familiarity versus unfamiliarity is the dynamic messaging systems that we had. We had a good amount of DMSs out through either temporary, or we're utilizing the city of Inglewood's permanent billboards that would show direction or parking information and that type of thing.
Great. Okay, our next question is going to be for Mark. The question was, how does Urban Logic handle data types that are inconsistent, for example, speed data?
So I hope I understand the question correctly, but if the question is around how we have data from disparate sources such as connected vehicles versus location-based service data, what we do is we work with both the data vendor and the local government to calibrate the data. So for example, we'll work with city-owned speed sensors and then test that against the different types of data sensors, like the data sources, and we'll identify where there's a confidence interval around it. These type of data sources are accurate during these types of days when you have this kind of a penetration rate. But once you kind of get, like I mentioned, when you get kind of late at night and people are at home in bed, then suddenly the accuracy of the data will decline. So we basically come up with a calibration quality assurance metric that we work with governments and our data vendors then to continuously refine and test that.
Great, thanks for answering that question. All right, Shane and Michael, you're up. So I have a question for you. It says, what was your approach for dealing with projects for government agencies, such as federal or state agencies, rather than private sector buildings? And I guess this was a twofer because it says, how are they handled along with security physical standoff requirements?
Thanks, Melissa. Yeah, I think there's a couple ways to answer that one because there's a couple things in there. Obviously, when construction happens through a federal government partner, for example, they may not be required to keep our stormwater regulations or other ideas that a locality makes. So there are exceptions that need to happen for other entities that are building things. On the security front, well, okay, so let's say, for example, Denver wanted to build a school and they needed to build a sidewalk. Well, that sidewalk is going to cost more because they have to temporarily detour the pedestrians into the street while they're building the sidewalk. That would be an example for the local agency. And then in terms of security, anti-terrorism or thinking about security concerns, those are more permanent things, like putting a bollard around an airport or something like that. Those aren't associated with an event or the construction. So we would be looking at that as in a review under a more permanent condition. Hope that answered the question.
I'm sure if it's not quite what they were looking for, remember, if we need to kind of clarify something, add it back in the question box. We're trying to answer as best we can from a written comment that you made. So if you would like us to further discuss something, please enter that. Jingwon, I'm going to ask you a question. I think maybe I saw where these were answered in your presentation, but just in case for clarification, because we did have a question on it, thought we might want to reiterate something. It says, did you account for evacuation destinations in your modeling and your evaluation?
Yes, that's a very good question. So in our evacuation analysis, we did including this mechanism as one of the control point for the city, or for the depend based on the needs. So far in our current one, because the city hasn't really had such a planning process yet. So in the destination to control destination, we use our current travel demand, the patterns that shows where they go. The destination include the shelters, the hotel in the region, and the stadium, all those locations, and also including the external area external to the city as a potential. We identify the percentage of the trips going to each of the locations, and then so in that case follow the based on the historical data. So this way we can control the generate the evacuation trip table and then apply the BTAs to estimate the evacuation traffic. And then later, when we know better about the hotspot and based on those locations, so this setup could be easily used by in the city's planning process to control which direction they're going to go. They're going to guide the evacuation trips going. So this is kind of like we provide a pretty flexible framework that could be easily incorporated into the city. And then also, I see the question also mentioned about departure time. And then, yes, so in the current setup, we did, because our evacuation travels is in the DTA process. So we did have the discretion of by time. So 15 minutes. So, and then for the evacuation travels, for example, if they have to finish in 1 hour or 2 hours, we did have the distribution because the evacuation trips cannot be released all at the same time. So we did set up, based on the historical data, we set up, distribution of the trips, how the distribution of the trips release to the network. So this way that we can show. So in that case, all the travel trips will not be loaded on the network at the same time, which can be progressively getting into the roadway. And then this way also it can be easily incorporated into the city's planning process is set up. And then see if they have a more detailed plan for the evacuation, they can certainly request the evacuation area, that residents in the evacuation area, to release their trips at a certain time, at the phase, in a different phase. Yeah. So
great. Thanks for that further clarification. That was interesting to hear some more on that, to make sure that people understand what you were doing. So thank you so much. All right, I think we still have several minutes for Q&A, and we have some other questions for our speakers. So I'm just going to kind of start back through the rotation. Back up to Tyler and Vanessa. What was the major traffic issue that you saw during the RAMS training event? Kind of one of your trials of your plan.
You guys hear me okay? Yeah. Anyway, I think the biggest thing we all hear it, it's communication. It was one of the first larger events, even though it wasn't that large. We had radio malfunction, some channels only going as far as certain arterials and not farther enough. Or if you were in certain floors in SoFi Stadium, you could get communication, but in the communication center, some people would not hear them. We had some communication or lack of communication on arrival of time of the traffic control officers, as well as the training of what they needed to do, as well as the sheriff department. So that created a trickling effect, and we couldn't deploy the traffic control because the TCOs were not there, and that delayed everything. And I think the biggest one, which the city does not have control over, was SoFi Stadium opened its doors much later than the fans arrived. So we automatically had a queuing effect prior to the opening, which against the regular Thursday day traffic just compounded. So those are some of the lessons learned. We just had another event, and a lot of those were completely improved and came on through without a hitch. But every event is a learning lesson.
Most definitely, and I like the way you kind of you spun that in your presentation. That while none of us expected COVID, it did offer some opportunity for you to test your plan and work through your plan. Not just all of a sudden big days here, but kind of small steps with some other events. So that's great. All right, Mark, I have a question for you. Just thinking about all the data sources that were out there, and you showed several in your presentation, what is the most exciting piece of data that you think that we have now, or you think is coming and we'll be able to use in our profession that maybe we didn't have, 10 years ago? Any thoughts on that? I'm hitting you cold with that because that wasn't in our chat box. But
No, thanks for that. I think I think a couple jump to mind right away. So one, location-based data has been incredibly powerful in helping understand people. And I'd say it's actually just a combination of location-based data, for example, where you can start to see how weather changes people's movement patterns, how different events. So exactly like we're talking about when there's a major sports event, when it's a rainy Thursday in March, people go home right away, so you get a surge of traffic. But if it's a sunny Saturday in May, traffic tends to dissipate over several hours, so there's no traffic bulge, but you do have an ability to harness like the economic opportunity for local bars and restaurants. So I think it's when you combine the pattern of data. So you have like not just the location-based data, but you have years of it, and then you also have combination of what are the sports events and what was the weather. So when you stack all of those data layers together, you can find really interesting and fairly predictive insights into how they collectively create a constellation effect that allows you to predict traffic, but also predict this impact on things like the local economy. So I think right now that's something that's possible today. That's the exciting part. And I think also the other thing we're starting to see is the reduction in cost of both sensors and processing of computer vision, because you're going to be able to start to get all kinds of attributes. So it's not just car, truck, pedestrian, but is it people in a stroller versus a wheelchair? Where are people jaywalking? And I think as those types of the cost of those sensors comes down, and you have the connectivity of things like 5G, those types of things are really going to change the way we run our cities and plan our mobility operations.
Great, thank you, and thank you for being flexible of me surprising you with that question.
Thanks for that.
I can't read and type at the same time, so I just had to surprise you with that one. All right, Shane and Michael, question on regarding the guidance of 72 hours to distinguish between that short and long-term closure. Do those hours need to be consecutive, or are they simply cumulative to trigger the use of the ped bike detour guidelines?
So, and with that distinguishing between short and long term, we're really trying to balance, recognizing that these requirements have an impact and a cost to contractors, and at the same time, there's a cost to users. So we're really trying to balance those two. So the 72 hours ends up effectively being 3 days of closures. And in that case, concurrent. If the contractor was to be doing multiple closures over a longer period of time, they would actually be applying for each of those separately. I think that's my understanding of it. And Denver also, the system tends to look in terms of days instead of, so if you actually had a really short-term closure, a couple hours, that would still be the equivalent of 1 permitted day. But yeah, it's sort of within the grounds of each permit. So if you were doing 1 closure each week, each one of those would likely be a separate permit. You wouldn't have a cumulative, you wouldn't be a long-term project with 3 once-a-week closures. And again, that's just trying to achieve that balance, if that makes sense.
Yes, thank you for that clarification. Jinghua, we have another question for you. Has there been an evacuation event that can be compared to the estimated congested and volumes that you talked about?
Yeah, unfortunately, we don't have the similar events data for the similar events in the city in the same location, but we do have such events, the wildfire events that did happen in recent years, in the nearby location, in the San Bernardino County and the Riverside County. So we actually using those data actually to compare to our results to look at the evacuation clearance time and the travel time, just for try to just look at to compare those information to see if they're consistent or not. Mm-hmm.
Great, thank you. All right, I think I just see one more question. It is for Tyler and Vanessa. I will ask our ITE staff that are helping me out if I've missed one as we're jumping around. Please bring it to my attention in the chat bod. But I have this question again for Tyler and Vanessa. It says, were reversible lanes considered for the peak flow to and from the stadium events?
Yeah, I can take that. We did consider reversible lanes, and we implemented it, and we decided to switch them up a little bit from the things that we saw the first time we ran them. I think there were some issues with the way the geometry was and where the TCOs wanted to be located within the intersection. And related to the closures, we also did a lot of closures. We planned on, during the outbound, one of our event plans was going to have, maybe the largest intersection of the whole area, Prairie and Century, was going to be just two-phase, no left turns on it. We totally closed down lefts and push vehicles through. After running a couple events, we realized that even though you sign it in a certain way, people might not drive it that way. So we put in little pockets, maybe a 10 minimum time on a left turn, just in case things don't go well. And that just kind of goes back into, this is pretty good for running a system and iterating towards what works and what doesn't, so that when we have a really truly big event, it isn't crippling the whole system.
Great, thank you. And we did have another question come in, so you can still enter questions. We have, I would say, about 8 more minutes before we have to finish. So if you do have a burning question, now is your time to ask. But I have a question, I believe it's for Jinghua. It says, is there a way to methodically develop scenarios for an evacuation event? Seems like maybe we lost her. Well, we may have to come back to that. Oh, here we come. Can you hear us again, Jinghua? You're on mute. You're still on mute. Maybe see if you can push the button up on the, get yourself unmuted again. If not, we type the question in the chat pod. If you can't unmute, maybe you can answer it in the chat pod, and maybe one of our organizers can put it over someplace where folks can see it. It says, is there a way to methodically develop scenarios for an evacuation event, was the question. So I don't have any other questions queued up. Is there any other piece of information that a speaker, any of the speakers would like to add before we go through some of the final items? All right, well, I'm going to go ahead and move into our final part of our discussion. I just want to thank again all our speakers for their great presentations, for the questions from our audience members, and the answers that our speakers provided. It sounded like at least maybe Tyler and Vanessa can go over to the Wander Room, maybe wave if you're somebody that can also go over to the Wander Room for a minute. And continue a conversation there with some of our audience members if they want to go into a more depth conversation. Again, you can go over to the conference platform where you selected this session, select Hallway Talk, and then go into the technical sessions area. As a reminder, to receive PDH credits, you must first view the entire webinar. Hopefully you just stayed with us this whole time. Complete the evaluation associated, and then credit your certificate will be unlocked. Your credit certificate will be unlocked and available under Certificates tab, located in the ITE Learning Hub account. The evaluation link for this technical session is also posted in the questions pod for the attendees to access. Also, the recording of the session will be available in the ITE Learning Hub within 48 hours for all meeting registrants. Thank you so much for attending today. On behalf of ITE and the International Board of Direction, we appreciate your attendance and your dedication to our profession. See you soon.